Hello everyone, my name is Kim. Today I'd like to introduce my parametric model for Qatar. This is project 2 for Arch 655 parametric modeling in design in 2018. The objective of this study is to develop parametric models to analyze the built environment and design performance to optimize building design and energy efficiency. This study has used Grasshopper and several applications such as Ladybug, Galapagos, and Conduit to understand how to develop visual programming and figure out data processing from the analysis. To analyze the built environment around the Dot Tower, I have modeled urban structures based on the Google map, but it was a little difficult to check exact building height and shape. I roughly modeled urban structures to test the influence of daylighting and the uh, microclimate into the tower. My first analysis was solar radiation analysis that was conducted using the Ladybug application. Also, I have used Abu Dhabi IWC weather data because that was the closest weather station for this simulation. Solar radiation analysis was analysis on the ground level that can be controlled by parameters, which can set up specific date and time. And then I also did some path diagram simulation that can show an annual sun path with temperatures for the tower. Sun path diagram refers to the sun location at a specific date and time. This is the side view. Also, I did a shading analysis. This simulation can show sun exposure hours at the wind solstice that can be used to optimize building shape and reduce solar radiation on the building environment. This is top view. We can understand the adjacent buildings can affect sun exposure hours and for each time, and we can understand which part can be shaded and which part can be getting more solar gain on the space. This is a perspective view. And then I did the wind profile analysis that can show what is prevailing wind direction and the speed. That is very important to predict wind speed change and canyon effect by adjacent buildings on the ground level. Also, vertical wind speed can show the changes of wind speed that should be increased. This information can be used for designing integrated wind turbines on the building, such as Bahrain World Trade Center. This is programming in Grasshopper for wind profile analysis. Also, this is plot demonstrates our monthly wind profile that is based on weather data to show prevailing wind direction and speed. This is dry bulb and the relative humidity analysis based on weather data. And then I have used the conduit application to show my simulation results and data analysis on the right screen. The advantage of conduit applications they can show the results as several types of plots such as pie chart, a line chart and bar chart on the Rhino. So I used the CDD HED calculations for pie chart and the vertical wind speed for bar chart. Also, driver of temperature, wind speed were used for line chart on the screen in Rhino. And then I also did Galapagos analysis that can find the optimized building shape based on solar radiation on the building surface. I only used the radii of circles at different heights as an independent parameter to determine the building shape. This is my final view. Here we can see on the left top there is CDD hours, and the left bottom is a vertical wind speed from the ground level to specific height, and the right side can show drive of temperature and wind speed for a year. And also we can see a driver with temperature plots and monthly wind speed plots and some path diagram and solar radiation on the ground level. This is perspective view. This is a view including building patterns, and this is my grasshopper modeling. Thank you.